established the sea ice outlook the first time starting in spring 2008, which invited the Arctic community to contribute their own predictions and their own rationale for a single number, which is the extent of sea ice remaining on the Arctic Ocean at the end of the melt season in late September. So that first year, they established a pattern of having 3 cycles, one in early June, one in early July, one in early August, all of them trying to predict what the September extent would be. And the sea ice outlook has continued since then. It was taken over by a project called Sea Ice Prediction Network, SIPN or SIPN, in 2014, which has enhanced it further, and you'll be seeing a little bit more of their work today as well. So it's been highly successful. We've had, as I said, 589 predictions contribute over the period of the sea ice outlook. Let's see. 2 articles form the basis of what I'm going to be talking about today. Those include the 2014 paper in the Geophysical Research Letters that was led by Julianne Struve, and a 2016 paper, actually it's about a month old and it's already risks getting out of date, published in Polar Geography by Julianne and myself. So for the first one, we covered the sea ice outlook over 2008 to 2013. The more recent one, we updated in several respects, including two further years of data. And incidentally, the second one in particular is, this is open access, which means anybody can download it from the journal's website. You don't need to have a subscription or a university library. So I said it was successful. This is the chart we have in the newer paper, which graphs the number of contributions to the sea ice outlook from 2008 to 2016. So started about 39 contributions, combining the June, July, and August cycles in 2008, and gradually rose over the years. So the last 2 years, we've been a bit over 100 individual contributions. Somewhere along the way, we started classifying these, of course, according to several general types of methods. And for the recent paper, Julianne went back and reclassified them. What you see here is 5 different categories of methods. The top group are the most sophisticated modeling methods that involve coupled ice, ocean, and atmosphere models. And as you can see, they've grown from nothing in the early years to becoming an increasingly significant fraction of the total. There are simpler models that just involve ice and ocean dynamics. There are mixed methods, which are some mixture of modeling and statistics. There are the purely statistical methods, which have always been the largest single part. And then a sort of catch-all group called heuristic, which is could be anything. Could be polls of individual scientists, or it could be somebody's guess based on an extrapolation or something else. A word about these. The statistical methods, by and large, try to predict September extent based on some set of inputs from the start of the season in previous years. And they treat the process of ice formation or ice melting sort of as a black box. That is, they don't try to represent physically what's happening. They just try to guess based on everything we've seen happen so far. And in contrast, the modeling efforts look inside that box and try to represent the physical interactions that give rise to the ice extent every year. And it appears, as you'll see later, that these things work differently in different years. There are years in which a statistical approach works better, and there are other years in which a modeling approach seems to have more success. So here's the context. The satellite era of sea ice measurements, we have a good internally consistent record going back to 1979. Other researchers like Walt Meyer have extended it back farther, but for most purposes, you'll see these graphs starting 1979. And the jagged red line here is the observed mean extent of sea ice on the Arctic Ocean in September. Each year, 1979 to 2016. And there's a curve that summarizes the overall somewhat steepening downward trend. So sea ice in any one year might be higher or lower than the year before, but the overall trend is downward. And I'll refer to this several times in the talk, but it's a kind of shorthand way to think of that curve as being climate and the jagged excursions above and below as being weather. The Arctic is warming, and the ice is melting more and more from both warmer air and warmer water, with maybe a different balance in different years. And that is driving the overall trend. But at any one year, other things intervene, the shape of the summer melting season. And that may cause it to be much higher or much lower or just even slightly off what's happening on average. Now, at lower right, you see the median of the July predictions from the sea ice outlook each year. So that's just including everything together, all the predictions by all methods that were made in July, and which is before you can really see how the summer has gone, though it's after you've seen the spring melt pond season, or at least some of it, which many people feel is critical to what happens later. You can see at a glance here that the predictions, those squares in the squares in the lower right corner, that is down here, are in the right neighborhood, climatically speaking, but they don't follow the actual observed values, these red dots, particularly well. And one way of describing that is to say that the predictions are tracking climate better than they are weather, which maybe is not at all surprising. This is a closer look, and it uses the same color conventions as the last graph. This is only 2008 to 2016, so this is here we're seeing only the years over which we have actually had sea ice outlook predictions. And the blue squares are the median July prediction each year from the sea ice outlook, whereas the red line is the observed sea ice extent. So this is, the colors mean the same thing they do here. That next graph is just this, this lower right-hand corner of the image. Something that's drawn onto this is that for each year you've got sort of an error, which is the distance from the median sea ice outlook to the observed extent that year. Some years the error is quite large. Some years the error is pretty modest. And I also shaded in an area here, which is it's called the interquartile range, or it's about the middle 50% of the sea ice outlook predictions. So what you see in this, and we noticed this first in the 2014 pattern, is what we call the pattern of easy and difficult years. Easy years are basically years when the observed sea ice extent more or less follows the climatic trend. And in that case, the median prediction may not be very far off, and the observed ice extent is well within the middle 50%, the interquartile range, the shaded area of the predictions. So this would be an example of 2008, a relatively easy to predict year in that the ice extent was more or less on climatology. The next year, 2009, was not so easy, and not only is the median ice extent quite away from the observed ice extent, but the observed ice extent actually lies well outside the middle 50% of the data. In fact, I think there may have been no individual predictions that were that high. So here we have another easy year, another easy year. 2012 was a very hard year because, like 2007, the sea ice extent dropped much lower than anyone expected it to. And then the next year, it rebounded much higher. So in both those cases, you see the median prediction here, the observed value here. The median was much too high. Seeing what had happened, the predictions went lower the next year, but ice went high. So this pattern of easy and difficult years is a fairly robust feature of the sea ice outlook record. One way of describing that is a graph we have. This is from the 2016 paper of observed changes from the previous year. How much was the sea ice this year different from what it was last year? So -1 would mean it was 1 million square kilometers less than last year. Plus 1.8 would mean it was almost 2 million square kilometers higher than it was the year before. So 2013, that's that sudden uptick I showed you, was almost 2 million kilometers more than it had been in the previous year. On the other hand, 2012, that downward jag that I showed you, was 1 million kilometers lower than it had been the previous year. And that correlates pretty well with the errors in the sea ice outlook. So in years when the observed sea ice extent is fairly close to what it was the year before, the predictions are fairly good. But when it's quite a ways away, the predictions are bad and in the same direction. And this is not happening because simply because everybody's guessing it's the same as it was the year before. Some of the procedures are doing that, but there are a lot of other things going on as well, and it seems like they all are to some degree misled by, or potentially misled by those years when the ice does something really unexpected. It goes somewhere really different from its trend. So looking just at 1 year, and this is new because this is a graph we've only had for about a week, the observed sea ice extent this year was something like 4.7 million square kilometers, averaged over the month of September. That was unusual in several respects, as you'll see in a minute, and it caught most of the predictions off guard. These are the June, July, and August heuristic predictions. These are the June, July, and August statistical predictions. And you can see the medians are well below where the value turned out, although we do have a few values that are at that point or even well above it. These are mixed methods, a very small group. These are the ice-ocean modeling methods and the ice-ocean atmosphere modeling. And this particular year, the modeling methods seem to have outperformed statistics. I believe last year it was the other way around. But we make these comparisons and publish them 3 times each summer as part of the sea ice outlook that is published on the ARCIS website. These box plots, I probably should have explained that. The horizontal line is the median each year, or each cycle, so this would be the median June prediction using statistical methods. The boxes themselves contain their interquartile range, or the middle 50%, and the whiskers here go out to the most extreme value, which could sometimes be an outlier. Here we have one outlier, most extreme value in each year. So returning to 2016, I talked about weather and climate, and 2016 was one of those years in which weather and climate, or which weather played a significant role. You have something that the models and the statistical procedures are mostly starting with, which is what things were like the year before and what are they like in the early season, say in May, before the melting has really started. They may be looking at melt ponds. They may be trying to have estimates of the thickness or the volume or the age of ice. But what they can't forecast very well is how the wind will blow, what storms will arise, or exactly where the currents will flow. in a particular year. And those things are what drive these large positive and negative excursions around the downward trend. And in 2016, as we'll see in a minute, the ice extent was actually quite low throughout much of the winter and spring. It was on pace to set a new record low for the whole year. But then, and that led to a number of low forecasts. But then the weather in the second half of the summer, or throughout the summer, was colder than expected, and those forecasts were not correct. And specifically what happened is that the actual minimum day of ice extent in 2016 was down somewhere around here, not much over 4 million square kilometers, and would have made 2016 probably the second lowest year on record. But the second half of September was much colder than usual, and there was a very rapid refreezing during late September that brought the average for the month much higher. Interestingly enough, both the low minimum on September 10th and the rapid refreezing in the second half of the month got a certain amount of press coverage in the popular press, by people even arguing that Arctic sea ice is disappearing, or that no, it isn't, it's perfectly healthy. There's been much less coverage of what's happened since September, which is that the refreeze, which was so rapid in late September, has to a large extent plateaued the last couple of weeks, so that we're back again around third lowest for this date for the year. So a lot of weather going on, and it's very hard to predict. Really, I think what we're seeing, and Julianne and I conclude this in the article, is that the Arctic is in a transitional state. That, as our friend Don Perovich put it, that the sea ice used to be easy to predict. There would always be a lot of it. And at some point in the future, it will be easy to predict again. There won't be very much. But right now, we're in this transitional state where what ice there is fairly thin and very subject to being moved around, melted or not melted, compacted, exported, basically pushed around by the summer weather. And that is what's making it hard to predict at this particular time. It's not the sort of stable, older ice pack that we had a generation ago. Okay, the next set of slides, I'm switching over to the ones Julianne prepared. And I will, if there are any questions about these, I'll try to answer them, but I may not be as good as I am about my own slides. The sea ice extent, she's just showing what I mentioned a minute ago. The sea ice extent reached its lowest maximum extent in 2012. That was on September 10th, its lowest one-day extent. But it also set record lows in January, February, April, May, and June. This graph shows the the March extent going back to 1979, and you see that March of this year was one of the lowest we had. So that led a lot of people to expect this would be a low year. The map on the right, blue indicates the March 2016 sea ice extent, or thickness rather, being much less than it was on average over the previous 5 years. So blue extent here, or rather blue thickness here, means it's less thick in March than it had been in the previous 5 years. And there are a few places where it is red in March, meaning somewhat more thick than it had been in the previous years. You see over much of the Arctic, the ice was thinner than it had been at the start of, well, March is the maximum ice extent. So even before the beginning of the melt season, there was less ice than we're used to, even compared with the last 5 years. So the melt season started very early. This is the map here shows to what extent was there more melting than normal at the onset of the melt season. So what we had in July and August and then September was relatively cold weather. So we started out with conditions very conducive to melting, but then we ended up in the actual summer weather having colder than expected conditions. So you had a setup that led a lot of people to expect this is going to be a very warm, very melty Arctic summer, and then we had low pressure systems set in, as the lower two maps there show, for much of the summer that kept things cloudy. So there was melting from below, from the relatively warm waters, but not as much melting as there normally is from above, from insolation from the 24-hour sunlight. Historically, summer cyclones were associated with larger sea ice extents. They do several things. One is they're cold. Another thing is they tend to spread the ice out, and when it's cold and you spread the ice out, there's more likelihood of freezing in the gaps that form between ice flows. That is no longer the case because, in part because of bottom melting, because the water in many cases is warmer. So if the cyclone is separating the ice and washing it around with the water and mixing up the top layer of the water with somewhat deeper, warmer water, then you can get very abrupt melting. And that played a role in the very low extent you saw in 2012. In that year, there was a major Arctic cyclone in August that caused more than 1 million square kilometers of ice to vanish in a very short time. On the other hand, there was a late August cyclone this year that mostly seemed to keep the ice dispersed and seemed to promote greater area. So again, hard to predict. Nevertheless, looking at the Arctic ice minimum extent, as of this year, and I don't think this has been updated to 2016, the 10 lowest extents on record have been, in fact, the last 10 years. And if you compare this past year with 2012, the map does this, and I think it probably bears closer study, but the sort of orangish areas here are areas where there was more ice than 2012, excuse me, less ice than 2012, and the light blue is areas where there was more ice than 2012, then the darker blue is more or less the same. So the extent is dominated by some things happening around the fringes here, which again are driven more by weather overall. Meanwhile, the climatic trend, if you apply the simplest possible summary, just a linear trend, 84,000 kilometers decrease per year on average. So where is this going? Julian drew this slide, which is a comparison of global climate models under several different emission scenarios, from the most pessimistic to the most hopeful. And there are attempts to project the sea ice extent in years ahead. And even under a pessimistic scenario, the average model run is not seeing a decline to below about 1 million square kilometers, which is a rough definition of virtually ice-free, until the second half of the 21st century. On the other hand, the observations are consistently running below what the models have been forecasting. So the global models are not capturing what's happening in the Arctic right now. You saw earlier that even specifically Arctic analyses are having a hard time forecasting it. The models are having an even harder time forecasting. So that's an inspiration for future.
Thanks, Larry. We received contributions from 7 different modeling centers, which we're very grateful for, and a total of 16 forecasts throughout the whole summer period. And both of these are all-time records. So this is the summer we've had the most submissions of these local forecasts, which is great. So I'll be showing over the next few slides the forecast evolution of the local forecast and the scale of this year's forecast, and briefly compare with last year. So I'll start by showing in this slide the CI's probability forecast from the June CI's outlook, and this is from 5 model contributions, and the model mean of all those contributions on your bottom right. And the CI's probability, it essentially is a forecast of the likelihood of there being CI's concentration of 15%, so CI's extent within the grid cell for September. So a value of 1 would be 100% chance of CI's in that grid cell, and 0 would be no ice. And the other thing that I show in this, let's see, in these plots, the black contour here, that is the observed September sea ice edge, or sea ice extent edge for observations this year. So by comparing the red masks or the red values and the black contour, you get a sense for how well or not well we did. And so one thing we could see in June is, for example, that models were quite consistent in how they forecast the sea ice probability along the Atlantic side of the Arctic. So if we compare this region in all models, they're very similar to each other. The model mean, therefore, is also captures that, and it does actually fall in with the observed sea ice edge really well. Now, on the East Siberian and the Beaufort or Alaskan side of the Arctic, there is quite a bit of disagreement between models. So when you take the model mean, you have a wider area where sea ice probabilities go from 0 to 1. And if we slide to now the August sea ice outlook forecast, here we see quite a bit of change. So the other aspect from these forecasts in June, so it's going back to June, is that the CI said that the model's forecast tends to be quite zonal. So there's not too many geographic features. Maybe the AWI model does have a tongue of sea ice into the East Siberian, but generally and the NRL model, but generally they're fairly zonal, or the CI said is fairly zonal, where by August we start to see a bit more of a geographic richness to that forecast. Now, it appears that this year, if we the other thing I'll do here is show the mean sea ice probability of all the models between June, July, and August, and you can see by August this tongue of sea ice into the Eastern Siberian that some are forecasting and others are not. So I'll go back to August here, and for example, the GFDL, NRL, NOAA forecasting this tongue. The AWI models, it's got a bit of a hint here, but it's mostly melted out, and the Met Office is somewhere in the middle, but also with a pretty big melt back, pretty close into the North Pole. Now, one thing we can do to assess or to have a feeling for uncertainty in these forecasts is that we can look at the standard deviation of these fields across the different models, and this can give you a sense for which regions are particularly uncertain, or the forecast is particularly uncertain, or where there's quite a certain forecast. And if we start with June, we can see that these values are pretty low on the Atlantic side, which reflects what I mentioned earlier, that the models are pretty consistent in that region, but fairly high values along the East Siberian and Alaskan side, and this uncertainty actually seems to increase as we get closer to September, which is interesting. So by the last sea ice outlook in August, this whole region where we had that arm of sea ice extending towards Wrangel Island, that's where models were really struggling, and some were melting all that sea ice, others were keeping it around, as we saw in the previous slide. Now, a way to measure the accuracy of these spatial forecasts is by measuring the Breyer score. And the Breyer score basically measures the difference between the forecast probability and the observed event, which will be 0 or 1. And so a value of 0 is a perfect forecast, the way the metric is constructed, and 1 is an erroneous forecast or zero skill forecast. So by looking at these plots, you can get a sense of where where the forecasts were struggling or had less skill and where they did pretty well. And again, this reflects what one could qualitatively see in the previous slides, that basically this region here in the East Siberian tended to be the one that was harder, was the Atlantic. The models were doing quite well. Now the numbers on the X labels, these numbers here, they are the Arctic mean Breyer score. So we take the whole Breyer score field here, and we area weight average it, and we get these numbers on the X labels. So it's a crude but pretty simple and way to kind of calculate the average skill for these forecasts for the Arctic. Now, for example, this is for August, and you can see values of about 0.1 for most models, and this month the AWI model did best. And when you look at the model mean, we get a value that tends to be pretty good too. Maybe not the best, but better than sort of the average of just the model skills, of the individual scores themselves. So if we do this for every month of the CIS outlook this year, this shows the average Breyer scores for the Arctic for the different models from June, July, and August, CIS probability forecast. And you can see that generally there is a slight improvement throughout the summer period, which is good. But you can see that individual models can actually lose skill as we go from June, July to August. So that's interesting, and that might be just the that this year that sort of sea ice edge sort of the characteristics of the sea ice edge around the East Siberian, Alaska, this sort of jagged, very jagged nature of it perhaps was particularly hard to forecast. And as Larry was alluding to, it's probably sort of very unpredictable atmospheric events during the latter part of the summer. Now, if we plot the model mean here, or the skill of model mean CIS probability forecast, it doesn't beat all the models, but it tends to do pretty well, and it does show that improvement from June, July, and August too. Now, the last thing I want to show, very interesting to compare with last year's skill score. So last year we had quite a few less submissions of CIS probability, but nevertheless, if we plot the mean Arctic scores from last year's forecast, obviously, in red, and the black dots represent this year's forecast, we can see that last year the models were slightly more skillful at predicting the observed CIS probability in 2015. And that might just indicate that this year was just a little harder or a slightly less predictable year. Again, the atmospheric patterns and the jagged nature of that sea ice edge probably led to slightly less skillful scores. And with that, that is the end of my section. So I'm going to pass on to Betsy or Muyin.
The presentations be posted later. We will get this presentation online but before the end of the week, hopefully by tomorrow, along with a list of attendees in the webinar. We'll have the video presentation archived and slides available as well. I'm going to go ahead and skip to the final slides so that we can give some information about that question. So you'll see on that slide where you'll be able to look for the presentation archives, and again, that's on the ARCIS website. So arcus.org/SIPN/meetings/webinars/archive. And once you get onto the ARCIS site, you'll also see that there's it's pretty easy to navigate around and visit previous webinar archives as well. And if you'd like to know more about the CIS Prediction Network activities and events, you can join the SIPN mailing list. That's also available online, or you can just click that that link that's on there right now. Helen wants to know, she wants to encourage people to join the SIPN mailing list. I hope folks have been joining. I think we've had some people on the social media, but SIPN and ARCIS have both been more and more active on social media, so we certainly encourage folks to join conversations with the rest of the community in that way. Well, I don't see any further questions, and so I want to once again thank Larry Hamilton and Ed Blanchard-Wigglesworth for their presentations today, and to Julianne Strova for providing additional slides so that her information can be incorporated in today's presentation, and to Nguyen Wang for organizing the whole series of SIPN webinars this year, and especially this one. If you have any information, I'm going to forward this, I believe, to the, I know Britt will be able to forward the slides to the online questionnaire and survey. We'd certainly like to have some feedback from everybody about how well the webinar went, suggestions about how to improve them in the future. So please do take time to respond to that. And thank you so much for participating, providing good questions and good discussion. And I think this will conclude today's webinar. Thank you very much.
Thank you.
Thank you.